All right, so we are sitting between you and the dinner poster reception. We'll try to keep this brief, but I thought it would be a good idea to have a set of panelists invited to the podium to share with us, have an interactive session to talk about what we have learned. I'm basically just receiving so much good ideas, and over the day, just the diversity and the amount of insights I could conceivably consume is getting beyond my capacity. I think it's making sense to have some plenary speakers and presenters in the last couple of days representing academia, government, and industry coming to the stage. Could you, those listed on this slide, come forward to the stage? Thank you. And we did have a set of questions, and we're completely open-minded to any questions our audience want to share and put forward for discussion. Again, the basic idea is to increase some dynamics and interactivity, because up to now, most of today's program is designed to be this way. So we hope this session will get some information back to this way. So these questions are just exactly serving that purpose. So one question I have for the audience is, I know the program's getting late, and I think we're going to have this designed to be concise and dynamic as much as we can. The first thing I want to ask the audience is, do you have any burning questions that you would like to ask panelists, ask me, or ask others in the audience? You want to break the ice in any way you want. 1, 2, 3. Okay, so let's get to the next part of the program. And I want to ask the panelists, I'm going to go from the far corner of the table, to pick one question you like most, you want to respond, or you might dislike most, however you want to choose, but a single question you would respond to from the list. I believe I gave each of you a piece of paper that includes all the questions. Yeah. Nancy.
Okay, great. So Xiaowen gave us these very easy questions to answer just before the last session. I wrote down some short ideas on all of them, and the one that I wrote down the most about was how to make the case for CyberGIS in 30 seconds. I think a domain perspective is needed for this. You know, I don't have one. I'm an aerospace engineer and a manager at a supercomputer center. But what I think resonated with me through several talks that I've heard over the last couple of days were, you know, we talk about the case for CyberGIS being, you know, improved speed, but not just that. I think Mark made some nice points in his talk about being used to thinking about problems in a certain way, and there might be, you know, certain ensemble studies you could do, parameter studies you could do, problems you could explore at more depth if you got an answer in, you know, a few seconds rather than a few days or a few weeks. So I think thinking about, in that way, speed enables you to think about some problems differently. I think looking at increased resolution, that's what we often see in supercomputing when people get larger computers. They don't necessarily run more. They usually run more fine-grained and more detailed simulations. And what does that show you? And what does that show you in CyberGIS? So I think that, you know, those kinds of explorations, this is more than 30 seconds, are the types of things that would make the case for CyberGIS for me.
2 30-second answers.
Yeah.
Thank you.
So the question that I was most interested in was the third one, which was what are the most important CyberGIS opportunities and challenges related to cyber infrastructure, big data, and space-time synthesis. And it's something that's come up a couple of times, and I alluded to in my talk. And it's this idea of moving from description to analysis. I think we have, especially with social data, there's an awful lot of it around, and it's very easy to visualize, and it's very easy to create seemingly obvious maps of distributions and so on. And I think that the real challenge is to try and go from that scoping out of the data, if you will, through some analysis steps. And of course, CyberGIS is incredibly important in that context because the data sets we're dealing with are larger than we ever have previously. So perhaps some of the analysis is a bit more mundane than we perhaps would get excited about in the first few instances, but just simply because there's so much data, I think it's certainly worth maximizing the potential of CyberGIS in that context.
Thank you.
So I looked at this and said, I've already had my chance to say what I thought about several of these questions. So I tried to focus on one that I hadn't had a chance to talk much about, which is number 6, which is actually a double question. There's 2 question marks in there, which is cheating a bit. And I interpreted it not as the science of CyberGIS, but science with CyberGIS, which I think is a distinction which you may not have been intending to make. Okay. And I suggested, I thought of how you might address this question, and I thought of the following approach, which I think is interesting and may lead to some traction. And that is to compare the supply of data, which we've been talking a lot about today, with the supply of questions. And there's been a lot of suggestion that in some areas, some domains, the supply of data far exceeds the supply of questions. We're question short. We're data rich. In effect, then, to argue that we're drowning in data, but in many domains, we're thirsty for theory. So I thought if we took one particular example, we might be able to explore this a little bit. And the example I thought of was tracks or trajectories, the movements of people or things through time and space, the world of time geography, and in which we have now extraordinarily fine temporal sampling of position and extraordinarily fine spatial accuracy. And our question then is, what can we do with it? So we're drowning in data, but we don't have clear questions necessarily that we want to ask of that kind of data. And I thought of an analogy here, which is other areas that have had to consider the same question of what happens when a science has plenty of data but lacks theory. And what we tend to do first, perhaps, is to visualize. But visualizing in the context of space-time tracks is a mess. You end up with a huge mass of spaghetti, which is very difficult to see any kind of order in at all. Then you go to taxonomy and classification. You say, how do I cluster these things? I'm looking for groupings, because that may suggest something. I look for patterns. And these, of course, are the fundamental tools of data mining. And one analogy we might draw is to the problem faced by Linnaeus when he set about trying to classify species. What made 2 species more similar? And so you might imagine that he went up several false directions. So he might have said, well, let's classify all the big species together and all the small species together. No, that doesn't work. Right? And what he ended up with, of course, was to realize that the bat, a tiny thing of 7 grams, was similar to the human and similar to the whale because they were all mammals and they were all vertebrates. And so he lumped them together, recognizing that size was quite misleading. And similarly, the lizard and the snake and the crocodile and the dinosaur all get lumped together because they're all reptiles. Well, there are vast ranges of different kinds of size and so on. So coming back to tracks, the question then would be, what makes tracks similar? Is it that two tracks are similar because they have the same origins and destinations in space and time, the same geometry in space and time? No, that's not very interesting. So what is it that makes tracks interesting? And Don Janelle and I worked on a data set of tracks many years ago. It wasn't digital. It was very crude. It had been collected by regular sampling, observations, surveys. And one thing we discovered was that one of the most easily defined and distinctive groups of tracks was the tracks made by single mothers with working children. Working children. Single working mothers with children. And they were distinguished by having a very distinct triangular track in the morning, going from home to daycare to work, and then the reverse of that track in the evening. And it didn't matter where they were starting from, where they were ending. It didn't matter what particular time was involved. They were distinctive, and they grouped together people who had a similar kind of approach to spatial behavior. Right? So what this suggests to me is that if we're to cluster, which is one of the first things you do when you try to sort through data, if we're to cluster, we need to be much more broad about our concept of similarity. What makes two things similar in space and time? And that's what we don't have a clear idea of at this point. It's not that they follow the same geometry precisely in space and time. Right? It's not simply distance in some multidimensional space. In order to cluster effectively, the problem faced by Linnaeus was to discover what the dimensions were. And they weren't simply size or weight or things like that. Right? So what this suggests is an area for research within the context of CyberGIS, which will help us make the first groping steps towards a theory of behavior in space and time. So back to my suggestion then, what we need to look for in terms of productive research are areas where we have tons of data, we're drowning in data, but we have no questions. We're thirsty for theory. And to think through what that means in terms of the very primitive elements of data mining, including, for example, measurement similarity, which is the basis of clustering.
Thanks. Sean.
Okay, so I'm also, the last question was also the one that intrigued me. So kind of one of the opportunities I see for CyberGIS is starting to look at non-traditional data sources. This obviously builds largely on my talk on so georeferenced social media, I think, is a non-traditional geographic source of data. It can be very valuable, but there's also more broadly the idea of citizen sensors. So just as Mark Geoghegan brought up, all these people carrying phones with the sensors that are currently on the phones, the ones that will be there in the future, I think is a great opportunity for gathering non-traditional data sources. So I think that's the opportunity. I think the challenge or the capabilities that needed to be able to analyze this data and start answering research questions is very similar to what Mike just said. I think we need to build in, and again, this is talking from my own perspective as a computer scientist, is data mining and machine learning. There's been a lot of exciting advances in data mining and machine learning over the last 10 years that I think can be brought to bear on a lot of the problems here, especially on these non-traditional data sources. And so also building upon what Mike was saying, I think we need to be comfortable with discovery-led investigation. So we might not know all the questions initially, but trying some exploratory work, and this is again where machine learning and data mining can come in. I think that exploratory investigation, and hopefully the questions will follow good questions, and we can develop the theory. I think we have the benefit in this domain that at least we're dealing with data that is grounded on the Earth. It's real. We can observe it in our day-to-day existence. I have another project on computational structural biology where all of our analysis is done through MD simulations of proteins, dynamic proteins. And there you don't have the benefit of kind of, the intuition about how things are. You really have to rely on an exploratory data analysis. So you have no choice. But I think here we need to become comfortable with some of the more exploratory tools.
Ling?
I think I'll look at the fourth question, the next desirable advances of and the remaining major impediments. talk about the impediments first, I think, is there's a significant change in philosophy and a learning curve to using CyberGIS compared to other technologies that we know. And I think that's an impediment that needs to be resolved in order for this to spread as widely as I think it could and to see its full potential. The other problem that I see that really needs a major solution, I would think fairly quickly, in order to show the utility of this with big data, is the I/O problem. And I would like to see it. We provided this project with the entire 10-meter data set, which Shawan talked about, of our USGS elevation data. It's about 2 terabytes
2 terabytes.
of data. Let's ingest all that at one time and do something with it. And right now, I don't think that's something you're looking at doing. But that's the kind of problem I think we need to be able to handle to be able to do something with big data. You have to look at it all at once, somehow. So those are 2 comments on impediments and advances.
Steve?
I guess that'll carry from there. I guess I'm going to go after the second one with a little bit of the first one. I guess first, key characteristics of CyberGIS. I'm going to take a little bit looser view of that and say CyberGIS is spatial, first off. It's analytic. We all do this because we want to solve some kind of problem. We're not just here to make nice pictures. And it leverages something about modern IT infrastructure, whether that be high-performance computing, parallel implementations, GPU stuff, distributed processing, cloud, whatever. So if we think of it that way, making a case for what is CyberGIS, I'd say CyberGIS is happening all around us already. Everybody's already doing it, they just don't know our jargon. They don't know the word CyberGIS. In many ways, I think CyberGIS is just the next evolution of the GIS platform. And as we've evolved the use of GIS across different platforms, we've continued to expand its user base. So, from mainframes and mini computers, we moved to Unix workstations, and then everybody could do it in their office, right? And then we went to Windows PCs, and a lot more people could do it, and we changed the user experience to be map-based, and a lot more people kind of understood it at that point. And then we put it on mobile devices, and now it's in the cloud. And by being in the cloud, suddenly we're sort of almost back to that original idea of it's hosted somewhere else, right? But what that means is there's some things we can do that make it a lot easier. So, what are some of the benefits, I guess, of the CyberGIS concept? I guess I would agree with, the other presenters today talking about asking larger problems at finer scales, being able to apply more computationally intensive algorithms to problems that we might not have tried to solve that way in the past. But I think a big piece of it is using new user experiences to make it easier to use. By making things faster, we can make the user experience more interactive, and making that experience more interactive makes it more exploratory. And I think ultimately what this is going to result in is a use by a much larger community, an order of magnitude larger community, I would suggest, of expanding the use of spatial analysis capabilities. So I guess a research question for us is, how do we make it easier to use, easier for people to ask spatial problems, but still maintain the scientific rigor of the results that they're generating through that easy user experience?
Thanks. Mark?
Thank you. I have a question too. I'm going to try and tackle the second question in 30 seconds or less. If I manage to do that, am I allowed to provide a short answer for question 4 as well?
2 birds. Go for it.
I think if I hadn't been a professor, I would have been a used car salesman, which is why I quite fancy question number 2. So question number 2, the answer goes something like this. Imagine that there was a 7.8 magnitude earthquake on the San Andreas Fault, let's say for the sake of argument, at 12:30 p.m. on a Tuesday. Which buildings and which infrastructure would be damaged? Where would the people be at that time? And which people would be most likely to be trapped, and where? And how would you route the emergency services to those people?
Thank you.
That's my answer. I think that was less than 30 seconds, so I'm going to have a go at question number 4. And I don't say this lightly, and I don't have an answer to it myself. But I think the answer, what are the major remaining impediments for CyberGIS? We have to find a way to make it relevant for the 4,000 other geographers that go to the AAG meeting. In most cyber infrastructures, the community as a whole has a vested interest in them, or large portions of the community. Here we're very marginalized on the edge of geography. What does it take to create tools and services that are actually useful to our 4,000 other colleagues? That would make it sustainable.
So a question to a question.
Yeah.
Maple.
Okay, I think I also probably addressing the last one, except that I think, since I already talked quite a bit of that, and I think what I'm really thinking, about all this cyber GIS and cyber infrastructure is, how do you do your analysis? It looks like that we have a lot of data. We are drowning in data. We can pretty much have unlimited computing power as a researcher if we can get access. So are we really, do we just try to find out by mining the data and explore the data and trying to find out, what I know before? Or actually I was started with a question and a theory, and I actually know something and try to find out something because of this data, and then trying to get, what is the relevant data for me? And, in what time, in what year, what place, and then maybe now I can do more actually because of this cyber infrastructure. So I think that it's hard to believe that, in my area of research, like the human behavior research, that we can just see, let's dump all the data in there and try to see what happens. Just like, I'm a big fan of visualization and also exploratory spatial data analysis. I like to explore, but it's not, like a lot of people say, how come I plot all this path and space-time path, how come I cannot see anything? And then I'm thinking that maybe you don't have a question, you don't know what you're looking for, and you really don't see anything because, just a whole bunch of lies floating around. And you really need to still have some idea what you're exploring. That means that we need to have a question. We already need to have some ideas, or if not theory may be going too far, but maybe we need to have some kind of conceptual models, even though maybe we will revise it eventually, and then we will explore and accept that now we have a lot more tools to do it. We can do a lot more experiment, and also we have a lot more data that it was not available to us before. So I think that maybe this is what I think, but obviously there can be some other opinion.
Well, thanks very much. That set of answers have got the questions well covered, except for the opportunities. So now I'd like to turn to audience. I already see multiple hands are raising. Judy, you need microphone.
We're streaming, so if you're not into a microphone.
There's a microphone. Thank you.
Thank you. So for the 5th question, about how to foster research across communities. Data sets could be distributed to people in different communities, and a conference could be set up, perhaps even this conference for next year, with a theme of collaboration. And so someone from another field, say, biology or anthropology or
geography.
Another history, yes. You could for example, only accept papers from a team of people from 2 different disciplines. That would encourage people from the other field to choose maybe one of their data sets to overlay with the base map, and someone from a geography or a computer science field to help with the analysis. And that way you could get some new research questions, which is, I think, a different one of those questions, and a way to stimulate this kind of collaboration.
Thank you. That's a very nice idea. I was suggesting before we broke up yesterday evening, I was suggesting you to go make new connections and see whether you could cross-fertilize ideas with the new connections you are making. So I want to do a quick poll here. How many of you have made more than 2 new connections? Wonderful. So that's pretty good. Our social networking is expanding. Any other questions and responses to what Ming?
Yeah, I think I'd like to address the first question, but I want to ask, there's 2 different type of definition about CyberGIS. I think the project itself is very focused on a very narrow definition. Traditional cyber infrastructure tied very well with high performance computing. But if we broaden using the broad definition of CyberGIS, anything related to the internet infrastructure is CyberGIS. So WebGIS, Internet GIS, are all in the category of CyberGIS. I think we need to broaden the scope of CyberGIS to attract more people and more users to participate on this, just like Mark just mentioned. How do we engage with other geographers? Yeah, that's my opinion.
Thank you. Any panelists want to respond to that?
Could I respond to Judith's earlier comment?
Please.
On question 5, because I think one way to think about that is to think about how previous generations of technology were managed to achieve similar things. And if we take the GIS example, from a period from, let's say, 1985 to 1995, we went through a period of virtually no recognition of GIS in any scientific domain, except perhaps for geography, to almost complete recognition in every scientific domain that had to deal with the surface of the Earth. And I think there were 3 things that I would identify as key to making that happen. One was missionaries. There were individuals in particular domains who took it on themselves to promote. In, for example, archaeology, there was Herb Mashner. In landscape ecology, there was Carol Johnston. Somehow these individuals managed to proselytize. The second was educational materials. We made it easy for people to offer courses. So getting the content of CyberGIS into the curriculum through the body of knowledge or whatever, I think is a crucial step. Making it easy for people to offer courses. And then the third was conferences, domain-specific conferences. Having communities like Landscape Ecology offer sessions in GIS within their conferences was a key. And I think we can do the same kind of thing in this area.
Yeah. Lee?
Mike, I would add one other point to that time period that happened, and that was the recognition that it was GIS science and not GIS. And I think that contributed to what you're talking about in large part. But I really wanted to comment on that same question, but in a different way. And that is, if you have your computer do a Google search or Yahoo or whatever engine you use and search on CyberGIS and see what you find. Shawan has a monopoly. For the first 3 or 4 pages when I did the search, every reference was to this project, either to here at Illinois or at San Diego or at Oak Ridge, or every one of those related to this project. So what I would suggest is we need to make that broader so the term CyberGIS is used in lots of other places.
Yeah. Hey, yes. Okay. Yeah. That's closely related to what Ming was suggesting. I think the project is defined with very specific objectives. One of the objectives is related to community participation, which is spearheaded by Team Niagers. I think through that leg of the project, we have our research interests well defined to understand the scope of community interests and the scope of CyberGIS, which is how this conference has become a forum. Since last year and this year, we expanded to be an international conference. With your participation, this conference is your conference for you to understand how relevant CyberGIS is to your interests and to your education and research. So clearly, you could think of CyberGIS as an evolution because this effort is really on the shoulder of giants before. But at the same time, as you could clearly hear over the day, there are major milestones and yardsticks ahead that might lead to revolutionary changes. The exciting thing is we don't know yet which yardsticks and milestones, if we break through, will lead to some very major revolutionary changes. I think that's one of the things this community could come together to work together, make new connections, help each other, collaborate, understand. One of the spirits of cyber infrastructure is about collaboration. It's about to tackle problems that individuals have a hard time to tackle, and coming together with the new tools and technologies, methods, nurturing new approaches to new theories. Because now we seem to be shorthanded in terms of theories, even questions we want to ask. We have time maybe for one final question. Dan, you want to say a few words about who you are? No?
Do that tomorrow.
All right.
So I just wanted to ask on the cyber side of things, on cyber infrastructure. If we think of cyber infrastructure as hardware, software, data storage, networks, people, education, if we could make one of those things, say, 10 times better than it was, would that be a leap forward in terms of CyberGIS? And if so, which one of them? And if not, what else is needed?
I would look to panelists first, the colleagues, and they're probably always an easy strategy. Who want to respond?
I'll have a go. I think if we could make any one of those things 10 times better, I think that would be a win. If you're asking us to choose which one of those we would prefer to make better, I would say community, because without a community to back it, it won't persist. It will go the way of many other cyber infrastructures that have been started and then have faltered. So I think that's the thing you need first. Now perhaps you wouldn't expect that to be the answer, but you've got to get the community right first in order to figure out how this will persist into the long term. The other problems can wait.
I think software and user interfaces spring to mind immediately for me for this community. That seems to be the biggest challenge is not so much the availability of hardware, things like that.
Other responses? I would add to that community argument Mark was making. I think education is another piece of our big puzzle. How to establish mechanisms to make the education for the future pipelines are able to cut across the different pieces of cyber infrastructure. The human, essentially, you could say it's a human, but I think it's related to community. This needs community recognition of the problems and challenges we have in the hands. I think it's a quite unprecedented way, at least the community loosely defined what we see here. Follow up. Yeah.
So just quickly to follow up, if people think community is the big question, is that what everybody's working on?
I'm going to repeat your question because this is live streamed. Well, based on the response, does that community notion is everybody's interest or everybody's focus here? Response directly to that comment? Okay, I could do it in the interest of time. Answer, I would, Tim, go ahead.
I feel that I have that responsibility as a co-PI of the CyberGIS project. So if it's not being done in the appropriate way, please let me know. what else I can do and what Mary can do to facilitate that process. Not that we're the only ones doing it, of course, but somebody needs to be in part responsible. Even if it's not me, it's Xiaowen. But and Xiaowen will just send it to me. So, yeah, so I'm happy. I just wrote down here, community-driven design of user interface for CyberGIS platform.
Thanks, Tim. My response was going to be, the project is funded to focus on software, tools, community-driven design for user interfaces, scalable fundamental building blocks result into long-term community services and utilities and capabilities. That's the focus of the project. But through the project, we bring the community together, hopefully understanding at large what this notion of CyberGIS is and what are the other dimensions of CyberGIS we need to consider comprehensively and synergistically, driven by sciences, as we talked about so far 2 days. Data-intensive sciences is what we're particularly concerned with. With that, I'm going to suggest we thank our panelists one more round again. And thank the speakers throughout the day for the very stimulating talks. And thank you all for your participation. We still have 2 things going on as we're speaking in parallel. One is student competition. They've been using our sandbox prototype of the CyberGIS Gateway since last weekend up to now. We pushed back some deadline because there were students who were very interested, want to participate. They thought they might not have enough time. So the cutoff will be tomorrow morning, and we'll set up some committee to evaluate their results. So as we're speaking, there are students working hard on those problems. Those are CyberGIS-based geospatial problem-solving cases. And of course, we have poster. All the lightning talks today, most of them will have posters set up. If you have questions, I'm sure you do, go to those posters and interact with the presenters, find out more details, because you could imagine there's just 10 minutes, you cannot really get into much details. But also we have NSF-sponsored graduate students and junior scholars. They did not present today for their lightning talks sessions we set up, either because they were initially not aware of this opportunity. Later, they became aware of this opportunity and supported by NSF, thankfully, for the generous support we received as a supplemental to the project. And those presenters will have their posters as well. And we have a poster competition. And some of you will be asked to be judges of the posters. And again, we'll set up a committee to evaluate the results of the judges. And tomorrow, the end of the day, we'll announce winners. With that, I'll let you go. Enjoy the food and enjoy the knowledge presented. Thank you.